In this video, again, I'm going to talk about the IP address subnetting. This is the second example. In the previous video, we learned about the IP address subnetting concepts, and also we designed one simple scenario, one simple example. Here we have another example 2. Let me to talk about the example 2. After that, we can solve it. This is the practice for us, and in this scenario we have a little more advanced for example IP addressing scenario, IP addressing example. Okay, let me to talk about this. We have a building with 4 rooms. 62 PCs reside in each room. Okay, the task is to subnetting 192.168.10/24 for these rooms. You know that here we have 4 rooms, as we mentioned before. Look at here, 4 rooms. Here we have 4 rooms, and in each room we have again same number of the pieces, 62 pieces. This means that our requirement include for example, configuring or designing 4 networks. In each network we have 62 pieces. Let me to solve this scenario in this notepad file. After that, we can compare our solution or our design with the design of the for example, this figure. Let me to start with the identifying the requirement. You know that we need 4 networks. In each network we have 62 hosts. Because of that, you know the formula: 2 to the power of, such as the previous scenario, 2 to the power of h minus 2 should be greater than or equal to for example 62. With this formula we can find the number of host bits that we need. Here, as you know, we have these results. The host bits that we need should be greater than or equal to 6. This is the host bits requirement. Okay, after that we need to calculate the subnet bits that we need. Here we have the similar formula: 2 to the power of subnet, okay, should be greater than or equal to the 4, because we need 4 rooms. Because of that, we need the 2 or more subnet bits. Okay, s greater than or equal to the 2. This means that finally we need s plus h. Okay, means 2 plus 6 bits, means we need 8 bits for this scenario. And you know that here we have 8 bits of host. Because of that, we can design this requirement. Look at here, and you know that in 192.168.10/24 by default we have 24 bits of networks and also 8 bits of hosts. And here we need only 8 bits, and this means that we can design it because we have 8 bits of host and we need only 8 bits for subnet and host. Because of that, we can design this scenario. This means that 6 plus 2, 8, okay, is less than or equal to the 8 bits that we have. This is possible. If we had, for example, 7 bits, we can't design this requirement. But let me start with the designing of the 4 networks, with each network 62 pieces or 62 IP address or 62, for example, hosts. Okay, look at here. This is the 192.168.10/24, and as you know, here we have 192.168.1. Okay, and all of the bits here is after the first 24 bits are the host bits. 8 bits of the host now is available. /24 means now the subnet mask is residing here. Okay, or the network part is the 192.168.1, and other part, the last octet, is the host octet. Okay, and you know that after our for example design, we need 2 bits of subnet, and also we need only 6 bits of hosts. You know that here now we have 8 bits of hosts, but for this requirement for 62 hosts we need only 6 bits of hosts. Because of that, we can give these 2 host bits to the network part. This is our design. Look at here, 192.168.1. I can design with the 2 bits of subnet, and after that 6 bits of the hosts. This means that in this scenario, we are using the subnet mask of /26. Why? Because the total number of network bits and subnet bits are 26 bits. This means if you want, you can write this value in decimal 255.255.255.192. This is the subnet mask of our subnets. Okay, now let me to design these networks. Here we have 2 bits of subnets. We can use different value in these 2 bits to creating different subnets. For example, SS or double S can be configured with 00, or can be used with 01. After that 10, okay, and then 11. This means that we can create 4 subnets with these 2 bits. Okay, the first subnet network address. You know that we need to find the network address of each network address. You know that for network address we need to use the host bits of the 0, and after that we need to find the broadcast address for each network, broadcast address. Okay, broadcast address, and after that the host address. Are the addresses between the network address and also our broadcast address. Let me to find this value. First, for network address, you know that we can write this value 192.168.1. Okay, here we are using the subnets as 00. Okay, and for network address we need to use all of these host bits as 0. Let me to write here 1, 2, 3, 4, 5, 6. That's it. /26. Okay, and for the second network, this is for the second network 192. Okay, 192.168.101. Again quad 6. Then 6. Okay, to /26. And after that 192.168.110.123.456 /26. Next networks, and this is the last network 192.168.111. Again 0000000. That's it, and /26. That's it. Okay, this is our 4 networks. Okay, and also if you want to find the broadcast address, you can use the host bit. You can use 1 in all of the host bits. For example, for broadcast address of the first network, we can use all of these bits as 161. Okay, and also for the second network, this is the broadcast of the second network. Let me to write here 192.168.101. Again, here we need to use 61, and after that here let me to write here for the third network. For third network, again we need to use the instead of all of the host bits 1, and after that the last network. This is the last network, the fourth network. Okay, 192.168.111. Again, here we have 111.111. Okay, let me to copy this design here. Okay, because I'm going to convert the binary values to decimal. You know that this is equal to 192.168.10/26. 10/26. Okay, and this is equal to 192.168.01, means 64/26. 64/26. And this is equal to 192.168.128/26, and here this is equal to 192.168.192/26. That's it. About the broadcast address, if you want, you can find the broadcast address 192.168.100 quad 1. If you calculate the quad 1 or convert the quad 1 to the binary, you will have the 63. Because of that, let me to write here 192.168.1.63/26. After that, here we have 192.168.101, means 127. Okay, and after that the next broadcast address for the next network is 192.168.1. Here if you calculate all of this or add all of these values, you will find the 191. And after that For the last networks, the broadcast address is 192.168.1.255. And you know that the host addresses are the addresses between these two values. For example, in the first network, the host addresses include 192.168.1.1.2